The angles of a quadrilateral are 75, 90 and 75. Find the measure of the fourth angle. Now in a quadrilateral we have four angles, that is A, say plus B, plus C, plus D, and this is 360. So you have 75 plus 90 plus 75 plus D equal to 360. So 240 plus D equal to 360. So D is 360 minus 240, which is equal to 120. Therefore the fourth angle equal to 120. Here the reason you've got to write sum of the angles of a quadrilateral are 360. Quadrilateral is 360. The angles of a quadrilateral are in a ratio 2:4:5:7. Find the angles. So let A be equal to 2x, B 4x, C 5x, and D 7x. We know A plus B plus C plus D 360. So 2x plus 4x plus 5x and 7x is 360. So we have 18x equal to 360. Your x is 360 over 18. So x is 20. So when we want to find A will be 2 into 20 because x is 20, 40. B will be 4 into 20, 80. And C will is 5x, so 5 into 20, 100. D will be 7 into x, 7 into 20, and that is 140. In the figure, ABCD is a trapezium in which AB is parallel to DC. Angle A is 55, angles B is 70. Find angle C and D. So trapezium, opposite lines here are parallel. So this is parallel. So we'll see co-interior angles. So you draw the U, parallel line, transversal, parallel line. So D and A is 180. So we write DC parallel to AB. So A plus D equal to 180. Reason? Co-interior angles. So 55 plus D equal to 180. D equal to 180 minus 55. So D equal to 125. There's another set of co-interior angles. Parallel line, transversal, parallel line. Yeah. So here again we can say B plus C 180 co-interior angles. So 70 plus C 180, C 180 minus 70, C 110 degrees. In the adjoining figure, ABCD is a square and EDC is an equilateral triangle. Prove AE equal to BE. So we have a square, so we means all sides equal, and the square is ABC. So this is a square. So remember, if ABC is a square, all the sides are equal. Let me write that. ABCD is a square. Therefore AB equal to BC equal to DC equal to AD. Sides of square. Equation 1. Then we have an equilateral triangle, and they said ADE is equilateral. So ADE here is equilateral. So triangle EDC is equilateral. All sides equal. ED equal to DC equal to EC. Now let's get on to the angles. Here the angles of an equilateral triangle we know are 60. So this angle is 60, this angle also is 60. So I'm going to write that. So angle EDC equal to angle ECD equal to 60. Reason, angles of equilateral triangle. And now when it comes to a square, the angle is 90. So this angle is 90 here, and this angle is also 90. Let's write that too. So angle CDA equal to angle DCB equal to 90. Angles of a square. Now when we add up both, what will we get? We'll get angle EDC plus angle CDA equal to angle ECD plus angle DCB, which is 90 plus 60, so 150. And what is this angle EDC plus CDA? Is this entire angle, this entire angle. How do we name that angle? We name it as angle EDA. And the next also is this entire angle 60, the red is 60 and the orange is 90. So that entire angle is equal to angle ECB, that is 150. Now if you take up these two triangles, we have this triangle and this triangle, you see they are congruent by which test? By SAS test. Here DE equal to EC, DA equal to CB, and this angle equal to this angle. So by SAS test the triangles are congruent. So we write that. So we have triangle EDA and triangle ECB. We have ED equal to EC, sides of square, size of triangle, that is not square, of equilateral triangle, and we have AD equal to BC. This is sides of square, and the angles are equal. Angles EDA, the central angle is equal. Let me mark in another color. See this angle here, the central angle here equal to this angle, 150, 150. Each angle is 150 that we have shown. So we have angle ETA equal to angle ECB equal to 150. So the triangles are congruent. Triangle EDA congruent to triangle ECB by SAS test. If the triangles are equal, the sides are equal by CP, CT. So I can say AE equal to BE by CP, CT. I'll write that. AE equal to BE by CP, CT. Let's go over this again. So I had this side equal to this side, sides of square. Then I have TE equal to EC, sides of equilateral triangle. And then I had this angle here, which is 60 plus 90, 150, 60 plus 90, 150. So by SAS test, the triangles were congruent. Which triangles? Triangle DE, this triangle here, maybe I should put it another color. I'll put it in okay, DEE A congruent to ECB by SAS test. So AE equal to BE by CP CT. Now the next part of the sum says show DAE is 15. Here's the figure again. We showed that this angle is 60 because it was the angle of an equilateral triangle, and we had this angle as 90 because it was the angle of a square. Therefore that entire angle was 150. So EDC equal to 60 and angle EDC CDA equal to 90. So when you add up here, you get angle EDC plus angle CDA equal to 60 plus 90, and here we get the full angle. This entire angle, which is angle EDA equal to 150. Then in the next we have seen that DA equal to DC. So DA equal to DC, sides of equilateral triangle. And then we also saw that DE is also equal to DC. DE is also equal to DC because it's sides of a equilateral triangle. This was sides of a square. So we have DE equal to DC, sides of equilateral triangle. So if DA equal to DC and DC equal to DE, so we can write DA equal to DE. So I mark that DA equal to DE and I'll erase this. You know, this entire angle was now, this angle was given as 150. Now look up in the triangle ADE. Look up this triangle. It is an isosceles triangle. Triangle DAE. In triangle DAE, AD equal to DE we have proved. So the base angles will be equal. So this angle here and this angle will be equal. That means angle DAE equal to angle DCA equal to x. Now x plus 150 equal to 180. This is our 150 here, this angle 150. So we'll have x equal to 15. So that was asked, angle DAE was asked. So angle DAE equal to 15 degrees. In the figure, BM is perpendicular to AC, so something must be 90, and DN perpendicular to AC also. So we have this and this 90. So two angles equal. And BM equal to DN. So here these are equal. And we have a pair of vertically opposite angles which we can mark on our own. So the two triangles are congruent by, have you seen, by AAS test. So if you take up triangle TNO and triangle BMO, you will say DN equal to BM, and that is given here. Then we'll mark this 90, 90, two angles 90. So angle DNO equal to angle BMO equal to 90. This also is given. And then the vertically opposite angles, angle DON equal to angle BOM, and that is vertically opposite angles. So the triangles are congruent. Triangles DNO is congruent to triangle BMO by AAS test. If they're equal, I can say DO equal to BO by CPCT. Now look at the figure and see. If BO equal to CO, what can I infer? I have BO equal to CO. So I can say that AC bisects or cuts into equal halves BD. BD is cut into two equal halves. One is BO. CBC is cut into two halves. One is DO and the other one is BO. And they're equal. So AC bisects BD. That's what we needed to prove. Find the measures of each angle of a parallelogram if one of its angle is 30 less than twice the smallest. So here is a parallelogram ABCD. So in parallelogram ABCD, the angles are A, B, C, D. One angle is 30 less than twice the smallest. So let's say A equal to X. So B is 30 less. 30 less means minus 30. Twice the smallest. Twice X. And we know A plus B is 180. Co-interior angles. The adjacent angles of a parallelogram are always supplementary. So A plus B equal to 180 because they always are co-interior angles. So X plus 2X minus 30, 180. 3X equal to 180 plus 30. So 3X is 210. X is 210 over 3, which is 70. So let's write the angles. So your angle A was X, which is 70. And angle A will also be equal to angle C. Opposite angles are equal. So C also is 70. When it comes to angle B, we saw angle B 2x minus 30. 70, x is 70 minus 30. 140 minus 30. 110. So this is 110. If B is 110, D also is 110. Because why is B equal to D? Opposite angles of parallelogram are equal. ABCD is a parallelogram, so we'll draw that. ABCD parallelogram. So we write ABCD is a parallelogram. AB is 9.5. So if AB is 9.5, DC is also 9.5. So AB 9.5 given. And we know AB equal to DC. Opposite sides of parallelogram are equal. So we'll write DC is also 9.5. And the other two sides are not given. We're going to take it as X. This is also equal. We'll take them as X and X. So you'll say let AD be equal to X. AD equal to BC will also equal to X. Again, opposite sides of parallelogram are equal. Now for the third part we have perimeter. The perimeter of ABCD is equal, in this case is 30 centimeter. They've given 30. But what is the perimeter equal to? AB plus BC plus DC plus AD equal to 30. So that is 9.5 plus X, 9.5 plus X equal to 30. So 19 plus 2X equal to 30. 2X would be equal to 11. So x is 11 by 2, so x is 5.5. Find the length of each side. So this is 5.5 and this is 5.5. In a parallelogram ABCD, point M and N are taken on the opposite sides of AB and CD respectively, such that AM equal to CN. So we mark that. AM equal to NC. Show that AC bisects MN. We'll mark two angles that are equal. This angle you already know are equal, vertically opposite. And there's yet another angle we can mark, alternate angles. See, this angle N will be equal to this by alternate angles. See the Z here. So we take up triangle NCO and triangle and MAO. First we'll write AM equal to NC given. Then we have the green angles, CNM equal to angle AMO, alternate angles. Then we take the blue angles, angle NOC equal to angle AOM, vertically opposite angles. So the triangle NCO congruent to triangle MAO by AAS test. Hence we can say that by CPCT we can now say AO equal to OC. So we write this OA equal to OC by CPCT. And also we can write OM equal to ON by CPCT. OM equal to ON by CPCT. So we can show that AC and AM bisect each other. They cut each other into equal halves. AC and MN bisect each other.